words must be changed. Is it on? Yes, it is. Solving polynomial equations algebraically and graphically. Test them for a semester. So in a previous math course, you learned how to solve linear and quadratics. Well, I guess in 10 linear and in 20 quadratics. In this course, we will solve polynomial equations of degree 3 or higher. The solutions to any equation are also called the roots of the equation. A polynomial function can have real roots or non-real roots. Real roots are any numbers belonging to the real number set, including rational and irrational numbers, like -5, 3/2, right? 3/5, -2/3. Non-real, sometimes called imaginary roots, are numbers such as the square root of -3, not a real number. The total number of roots for a polynomial equation is equal to the degree of the polynomial equation. So if it's the 5th degree, it has 5 roots made up of the number of real roots and the number of non-real roots. And that has to equal the degree of the polynomial. It is beyond the scope of this course to evaluate what the non-real roots are. So we won't be evaluating them, but we will say, oh, and there's 2 non-real roots, or something along those lines. Review. If you remember, a polynomial equation of degree 2, such as ax squared plus bx plus c equals 0, can be solved by graphing, factoring, completing the square, also known as square root principle, or the quadratic formula. To find the solution graphically, there's 2 slightly different methods which can be used. You can graph y equals the left side of the equation, and y equals the left side, right side. And what you want to find, where's your solution if you graph left and right side? You're looking for the blank coordinates of the point or points of. So it's the x coordinates of the point or points of intersection. So you're just saying, where they meet, their y value must be the same, right? They intersect, their y value is the same. We're interested in, so what's the x value that gives us that? Because the solutions are x values. Method 2, the zero method, a much better method. You rewrite the equation so one side is equal to 0. You graph the non-zero side of the equation. Graphing the 0 side. Actually, I would also graph the 0 side, because that way I find intersects instead of zeros, which I find more pleasant to do on the calculator. And then the value of the, what are we looking for now? X-intercepts. Yeah. So we're looking for the X-intercepts. So the nice thing about the zero method is, you know you're looking along that x-axis, right? You don't have to worry about, oh, there's some intersection off my screen and I've got to readjust everything. So the value of the x-intercepts of the graph, or the blank of the function, so they're the zeros of the function. Remember, the function is y equals, it's the whole curve. We want where that's 0, are equal to the solution, or the real. So it's the x-intercepts of the graph, the zeros of the function, or the roots. Yeah, so the real roots of the equation. Determine the solution x squared minus 4 equals 0 algebraically using excuse me, 2 different methods. So it's a difference of squares. We can factor it. So by factoring, we got x squared minus 4 equals 0. The difference of squares, it becomes x plus 2, x minus 2 is equal to 0. And we solve that and we say x is equal to -2 or +2, or maybe we say x is plus or minus 2. Seems we have both solutions, both the positive and negative value. And if we want to solve by another method, we could use the square root principle. Okay, so square root principle, that was factoring square root principle. So there we say, so we got x squared minus 4 is equal to 0. We isolate the squared, getting x squared is equal to 4. and then we square root both sides, right? So by isolating the squared term, we can then square root, and we end up with x is equal to what? Now we say plus or minus 2. So the roots of the equation above are 2 and negative 2, right? And they're real roots. So 2 and negative 2. And there are 2 real roots. Since there are, how many? 2 distinct, which just means different, real roots, and the degree is 2, then how many non-real roots are there? There are none. Okay? There are no non-real roots. Verify your answer graphically using the zero method. Okay, so if you graph this, you know what it looks like. I mean, it's a quadratic that's shifted down 4 units, right? So if you graph this, this is what you would get. You would find these roots. Okay, so to solve graphically, well, we got to graph it. Y equals, it was x squared minus 4, x squared minus 4 with an actual minus sign. Now, when I do this, I'm also going to graph y2 as 0. That way I can find intersects. Zeros on the calculator is a pain because you got to go left, right, and guess. Intersects on the calculator are nice. You just move to there and you hit enter 3 times. Okay, so I do the intersect method. So if I graph this, and then you say, well, you know, we can adjust the window a bit, right? So there's my y equals 0. So this is like 2, so maybe we'll go -5 to 5. So we're going to state our window. So I'm graphing y1 is equal to x squared minus 4. I have an x window of, let's say we go -5 to 5 by 1s, and a y window. We need to go below. We know it goes to -4, so let's go from -6, and let's go up to 10, and we'll go by 2s. So we adjust the window, -5 to 5, and we said -6 would do. So -6, 10, go by 2s, hit graph. Kind of easier on the eyes this way, more obvious. And then we need to find the values of the x-intercepts, right? In this case, it would be the intersection. So I go second count. 5 is intersect. Okay, I'm just going to do one of them. So I just move to about the point of intersection, hit enter 3 times, and x is equal to 2. So we then find the values of the x-intercepts. Find the values. So solving graphically, find the values of the x-intercepts. So part of you doing a graphical solution is to say, here's what I'm graphing, right? If it's y1 is the left side, y2 is the right side. Part of solving graphically is to then state your window. What window am I using for this? And it should be reasonable. And then part of it is say, well, what am I doing? I'm finding, in this case, finding the values of the x-intercepts. If we were doing y1 equals x squared and y2 equals 4, we would be finding the x-coordinates of the points of intersection of the two. Okay, so that's the 2 graphing methods. Try solving the following equation algebraically. Okay, does it factor x squared plus 4? No, it's a sum of squares, right? So all we could do is maybe let's try square root principle then. So I get x squared is equal to -4, so x is plus or minus the root of -4. So what do we do? So there's no real solution, is there? Right? I can't take the square root of a negative. I'm sure there's no so that's not a real number right here. Not a real number. Not the -4, but the square root. So previously we would say there's no solution or no real roots, right? That was the 20-1 explanation. No solution, no real roots. Since this equation is of degree 2 and has how many real roots? Then it has how many non-real roots? 2. Okay, and those are positive the square root of -4 and negative the square root of -4, but it's beyond the scope, right? We're not going to ask you what are the values of the non-real roots. It's really just identifying how many of them there are. Try solving this graphically using the zero method. So, okay, same deal. I'm going to graph y equals x squared, but this time plus 4. Take graph, and we could say, oh, well, no x-intercepts, right? No x-intercepts, there's no solution. So using graphically, so we're doing this, that's a 4. I think the same window is appropriate, right? So again, what are you going to show, right? We're going to show y1 is equal to x squared plus 4. So you're showing, here's the equation I'm going to graph, right? So we say graphically determine, this is what you got to show, right? What does determine? It means show your work. What am I doing? I'm graphing y1 equals x squared plus 4. I'm using an x window of -5 to 5 by 1s, using a y window of -6 to 10 by 2s, okay, and that was enough to show us what's going on. And we could adjust the window so you could see a bit more, but why bother? I've sketched out the graph, right, and I'm saying there are no x-intercepts, so no x-intercepts, which leads to no solution, right, and really no real roots, right, therefore no solution. Conclusion, oh, there's one small tiny change at the top of the first page, which is 4 pages back. So in other words, equals the degree of the polynomial equation. So just write in the word equation here. It's the degree of the polynomial equation. The first edit on here. Okay, next one doesn't come for a little while. All right, here we are. Polynomials of degree 3 or higher. For the polynomial equation given by blah, solve algebraically. All right, so to do an algebraic solution, what's our first step? Set it equal to 0, right? So we've got 5x cubed minus 7x squared minus 8x plus 4 is equal to 0. Okay, so we've got a cubic. Move those terms over. We set the right-hand side to 0. We say, what are the potential integral zeros? Plus or minus, you can just rhyme them off. 1, 2, 4. Plus or minus 1. Plus or minus 2. Plus or minus 4. Okay, we could graph this and then see, is 1 a good one? We could just try throwing a 1 in there. So if I put a 1 in, I'm going to get a 9 minus a 15. So 1 isn't going to work. So then we could try a -1, and that'll make that like -5, and this will become a plus. And this will be a plus. So we've got -5 plus 12, and we've got a +7, or -7. Okay, that's negative, that's positive. Oh, that'll be positive. Yeah, so -5 plus 12 minus 7. I think that'll do it, right? -5 plus 12 is 7 minus 7. Okay, so we think, and again, you could just graph this and then find, oh, it looks like, what did I say, -1? Looks like -1 is a root. So what am I going to do? I'm going to divide by x plus 1. And what we're going to do is turn the cubic into the linear factor, x plus 1, and a quadratic factor, right? Then we can just factor the quadratic, and we have our solution. Because we're trying to solve, right? So what are the values of x that make this 0? Okay, so we fill this in 5, -7, -8, 4, 5, -12, and -12, 4, 4, 0. Okay, so hopefully not surprisingly, that works. Okay, no change yet. we have a remainder of 0 here, which is what we wanted. So we now know that this polynomial will be x plus 1 and 5x squared minus 12x plus 4. And that's equal to 0, right? That's the equation. Okay, so now we got to factor, hopefully it factors. So if it does, it's got to be a 5x and an x. And it's probably 2 and 2, which will give me 10 and 12, both minus, yeah, that'll do it. Okay, so you factor it, right? Whatever method you use, right? Nobody cares how you factor, just get the factored form, check. 5x squared minus 10x minus 2x is minus 12x plus 4. If this is wrong, so is everything from that point on, right? Which was easily verifiable by actually graphing and looking at the graph. So if you get that wrong and then you didn't bother to graph it, you hand it in like 10 minutes early, and it's like, I couldn't be bothered to graph it, then I couldn't be bothered to give you any marks for it, because you should obviously have seen that, what you put here, you had the wrong sign. So you had the wrong root. Okay, so what's the solution? Well, here, detailed. So x plus 1 equals 0, which means x is negative 1. 5x minus 2 is equal to 0, which means 5x is equal to 2, and x is equal to 2/5. And x minus 2 is equal to 0, so x is 2. So the real roots of the equation above, and we're going to list it as a set of numbers. Okay, so there's the set of numbers, right? So the roots are a set of numbers. The numbers are negative 1, positive 2/5, and positive 2. Did anybody graph it? Does this match up with the graph? I mean, the 2/5 just looks like it's almost halfway between 0 and 1. Nobody graphed it? All right, let's go graph it. Y equals, what was the original? 5x squared minus 5x cubed, 5x cubed minus 7x squared. I didn't cube it. There, cubed, 5x cubed minus 7x squared minus 8x minus 8x plus 4. I'm going to go zoom standard just to return it to a standard window. And I want to see negative 1. I want to see something that's not quite at a half, and I want to see a 2. Okay, good enough, right? Looks good to me. If I wanted to check it, I would check this root. But I can also look in the table. That's another way to find your roots. If you're looking for what do I divide by, what's the root, go into the table, look for the zeros. Okay, so hey, what are the roots? Well, the value of x, so negative 1, right? There's the negative 1. That's why we divided by x plus 1. That's a root. Okay, you don't even worry about the graph. You can just go into the table. Right? What are you looking for? I know it's 1 plus or minus 1, 2, or 4. So if I go up as high as negative 4 here, right? Here's my potential integral zeros. Negative 4, negative 2, negative 1, 1, 2, and 4. Okay, and then 2 of those are actually zeros, right? So they can be used, so you divide and turn your cubic into a quadratic, which then hopefully can be factored. Okay, how many real roots are there? There are 3 real roots. And the equation is of degree 3. So there are how many non-real roots? There are 0 non-real roots. Since the graph has 3 distinct real roots, the corresponding graph of the function when using the 0 method has 3 X-intercepts. What's the word that has to be changed? Since the equation, so change graph. The equation has roots. A graph has intercepts, right? So from this point forward, we're doing a lot of changing of the word graph to the word equation, I think, right? It's just a bad wording in the thing. Since the graph doesn't have roots, the graph has X-intercepts. Since the equation has 3 distinct real roots, blah, blah, blah. Solve the equation using both graphical methods. You must describe your process and include a window setting. Okay, so method 1 was to go y equals. So y1 is the left-hand side of the equation, which was 5x cubed minus 7x squared. Y2 is the right-hand side of the equation, which is 8x minus 4. Okay, so I'm just going to squared, delete. Down here, this becomes 8x plus 4. Minus 4. Minus 4. That should be plus 4. No, that should be minus 4. Minus. Okay. I'm going to go zoom standard. So just starting a standard window, just what am I looking at? Can I see it all on here? Or do I have to adjust? So, okay, that's the cubic. That's the, you know the nice thing about the color? This is Y1. The blue one will be Y2. Ah, and there's Y2. Okay, otherwise you're looking at two gray ones. So somewhere here, somewhere here, somewhere here. So I don't need to go that far on the x's. Let's say we go -5 to 5, but I do need to go a little bit higher on the, do we even need to go -5? Let's go 1, 2, 3. There's 3. 1, 2, 3. Yeah, -3 to 3 would work, right? Okay, so let's do that. So now I'm going to say, okay, so my x, I'm going to go -3 to 3 by 1, and my y, I'm going to go -15 to 15 by, let's go by 5s, because that goes into everything. So reset the window, -3 to 3 by 1s, -5, 15 to 15 by 5s. Regraph. Okay, there's my cubic. Now we got a linear, the 8x minus 4. There we go. Okay, and now we're going to find, so now you say, find the x values of the points of intersection. All right, so find the x values of the points of intersection. Okay, and if we did that, then we would say the x's are equal to -1, 2/5, and 2, or a set consisting of those values, right? I'll do one of them. Let's just do the 2/5 one. Second calc, so I'm looking for an intersect, and it's go, and it's, oh my god. Okay, and it's 0.4, right? 0.4, which is 2/5. So method 2 is to rearrange. Y1 is equal to 5x cubed minus 7x squared minus 8x plus 4. I am also going to graph y2 is equal to 0. I prefer that to doing the zeros. If you do the zeros, it doesn't matter. Okay, I just like this because then I do an intersection. Now, can we use the same windows? Be an interesting question. So we got 5x minus 7x plus 8x minus 4. And go down here, clear that, put in a 0.
It's 8. It's -8 plus minus 8.
All right. Great. If you realize that happened, or you're graphing and something goes on, just hit the on button. That'll stop the calculator doing what it's doing, and then you can go back, right? Otherwise, you gotta let it graph. So it's minus 8x plus 4, right? Minus plus. Okay, how's this window? Yeah, it's going to be pretty good, right? Because really we're just finding those X-intercepts, which we already know the values of. So this window works as well, so we can just use the same window. So X, -3 to 3 by 1. Now, you know, I mean, on a test, you're not doing both of these, right? If we say solve graphically, you're choosing one of the methods. What do we use? Negative 15 to 15 by 5s. Okay, that works. Oh, if we're solving graphically, we should draw the graph, right? So sorry, I didn't do that for the last one. So we should draw the graph. Look like this. And this, right? So draw the graph on, right? A sketch of the graph, right? Good enough. And indicate the point. So this one, and this one, right? So do an indication. And so over here, same deal, right? So we're sketching, so it does this. Okay, and then indicate the points, right? This is what I'm finding. Okay, and then we're saying find the values of the x-intercepts. So find the values. You need to state that, right? So here are my equations, if you're using this. Find the values of the x-intercepts. And state those values. Good. All right. So I don't think we're going to tell you by method 1, right? It's like, what's method 1? So, but we may say graphically determine. Then that's what you have to do, right? Here's y1. Here's y2. Here's my window, here's a sketch, here's what I'm finding, and here are the values of those. X cubed minus x minus 6 equals 0. Solve algebraically. Okay, so what are my PIZs? Okay, plus or minus 1, 2, 3, or 6. So 1's not going to work, right? You get like 1 minus 1 minus 6, and negative 1 won't work. You get negative 1 minus negative 1 minus 6. So let's try 2. Let's give 2 a shot. So try x equals 2, which is going to be 8 minus 2 minus 6, which will actually work, right? So we know 2 should work just based on evaluating. So what am I dividing by? Okay, so set up your division, right? You write the next line. Let's see how your synthetic division is. So did you remember the 0? 1, 0, negative 1, 6? Okay. If you didn't remember the 0, then you'll see one on the quiz, right? It's like, oh, see that 0. Yeah. Okay. You need an x squared, right? So you have to count down. If you didn't write the 0, you know what you do when you look at this? Just read it back to yourself. So if you wrote this, 1, negative 6, right? That's what you wrote. Then you say this is, so all I'm doing is taking these 3 numbers, right? So this is, that's the constant, that's the x. This is x squared minus x minus 6. At which point you should have a little cognitive disconnect. No, it's a cube. Oh, I forgot that there are 0 x squareds. So this is constant term, the x term, the squared term, the cube. This is x cubed minus x minus 6. So just a little check that you can run 2, negative 4, 3, ran out of ink, 3, and 0. Yeah, I know. Virtual ink. Okay, so then, now, what am I looking at? Oh, here we go. Just looking to see what changes happen. It's in D, there's a change in D. So in D, change graph to equation. So since the graph, so in part D, change the word graph to equation. I'm going to do that now, before we. Since the equation. Okay, but wait, we're not done yet. Okay, so what have we got? We know that x minus 2 times x squared minus 2x plus 3 is equal to 0. I need two numbers that multiply to 3 and add up to 2. That's going to be tough to find. Because the only numbers that multiply to 3 are 1 and 3, and I cannot get a negative 2 out of a 1. Oh, it's plus 2. Okay, two numbers that multiply to 3 and add to 2. Still can't find them. So how do we solve this? The quadratic formula. Okay. So we have a quadratic factor, x squared plus 2x plus 3, which we cannot factor into linear factors, right? Which means that our other two roots are, like x, whatever, 2 plus or minus root 3 over 7 or something. So it's not over 7, obviously. All right, so let's go over here. So we have x squared plus 2x plus 3. So A is 1, B is 2, C is 3. So it's as easy as 1, 2, 3. And we just got to fill in the numbers. So we've got negative 2, b squared, 2 squared minus 4 times 1 times 3 over 2 times 1, which is just 2. So x is equal to negative 2 plus or minus. So I've got 4 minus 12 is negative 8, which could be a problem. Right, so there's no real roots. Well, why bother? There's no real roots. Right? You're not expected to find the non-real. Right? So if there's no real roots, then they are non-real, and you're not expected to determine the non-real roots. And yet you could simplify, right? I would take out a root 4, leaving a negative 2 underneath, right? And then, but it's work that is like, why? Why did you do this? You didn't need to. So, no real roots. Actually, if you remember back to 20, so think about 20 and think about the discriminant, right? B squared minus 4ac. And here's how I think about the discriminant. B squared is always positive, so it doesn't matter what B is. This is going to be a positive value. Minus, okay, if A and C are both positive, then it's going to be minus something, right? You're going minus. Now, if B squared is bigger than that, it's fine. You'll have values. But if B squared is not larger than that, so in this case 4 and 12, then we know, right? So you could just do the discriminant and say B squared minus 4ac is less than 0, therefore there are no real roots. I'm going to give you permission. Other class, I don't know, man. Maybe they got to show the whole thing. But, I do that here just because, hey, if A and C are positive, I know I'm subtracting something. And so instead of doing all of this, why don't I just sort of do b squared minus 4ac in my head and go 4 minus 12? Now I would then have to show it, right? You could just go b squared minus 4ac is equal to 2 squared minus 4 times 1 times 3 is equal to negative 8. The discriminant is negative, there are no real roots. Okay? That's a legit conclusion from that, as opposed to having to work this all out and then say there are no real roots. So the real roots of the above equation, what's the real root? 2. So the real root is 2. The equation is of degree 3, and we'll has the real root's 2, so we shouldn't say 0 here. So it has one real root, or roots, and 2. And here are the 2, right? It's negative 2 plus the square root of negative 8 over 2, and it's negative 2 minus the square root of negative 8 over 2, which we're not worried about the non-real. If we're electrical engineers, we're worried about them. They use complex numbers, right? And stuff. But we're not yet. Well, never will be. You're not yet. Since the equation has one distinct real root, the corresponding graph, when using the zero method, will have one x-intercept. Verify this by graphing. What was the equation? I'm just going to graph it here. What's the equation? X cubed minus x minus 6. Y equals x. It's just faster on this. Minus x minus 6. There we go. One real root 2 non-real root, well, they're not on there, right? There's no real roots. So 1 real root, right? We're just seeing the 1. So we know a cubic must have at least blank real roots. What's in the blank? It's got to have at least 1, right? Because it's got to go from Q3 to Q1 or Q2 to Q4. That's 3-2 then, right? It's down in Q3 to up in Q1, or it's up in Q2 to down in Q2. So it has to go through. As a matter of fact, we can generalize and say every blank degree polynomial must have at least 1 real root. Every odd degree polynomial equation must have at least 1 real root. Even polynomial, you don't need real root. Well, we just saw that with the 2. Same thing with the 4 or 6, right? It can open up and be above, it can open down and be below. But odd degree must have at least 1 real root. Verify this by graphing. Check. For the polynomial equation, really, solve algebraically. Okay, so what should we do? Okay, so we're going to have to do what with this? Expand this out, move that over, get it equal to 0. Okay, so what do we get? X to the 4th plus x minus 7x squared minus 5x. That's good. Now I don't have to select any terms. Thank you. I'd like to say I do this on purpose, but it's good though. I got to get you trained up for 31, so when the same stuff happens, it's like, yeah. Oh, you know, 2 pages ago, shouldn't that have been a 2? Thank you. Let's erase everything. Bring lots of extra paper, that's all. X to the 4th plus x cubed minus 7x squared minus 5x plus 10. Our potential integral zeros are 1, 2, 5, and 10, right? So let's start with 10. So we know between 10,000 plus 1,000. So, okay, does 1 work? What will 1 give us? 1, 2, negative 5, negative 10. Yeah, hey, 1 works. Nice. Okay, so 1 works. So we're going to say try x equals 1, which means I'm dividing by x minus 1. And we have all of the terms, so we don't have to worry about putting a 0 as a placeholder anywhere. So it's 1, 1, negative 7, negative 5, 10, 1, negative 1, 2, negative 2, 5, negative 5, 10, negative 10. That, oh, negative 5, positive 5, negative 10, 10, 10, 10, 0. Okay. If I don't get a 0, then I know either I messed up when I stuck a 1 into the equation, right? Because remember, the remainder theorem says the remainder when divided by x minus a is p of a, so I put in p of 1. So if I don't get a remainder of 0, then either I messed up when I stuck the 1 in, or I messed up my division, which for the first time today happened. So. Okay, so what do we now have? So we now have an x minus 1 as a factor, and we've got, okay, this will be cubed, right? So degree 4, then we have a degree 3. So we got x cubed, 2x squared, minus 5x minus 10. Okay, so let's now divide. So we need something. And again, I can go back, well, I can go to this, x cubed plus 2x squared minus 5x minus 10, and try a number. Okay. Now, negative 1 isn't going to work. If it didn't work in the original, it's not about to work in here. Let's just try it 2. Try x equals 2. So what am I going to divide by? X minus 2. What am I dividing into? The cubic now, right? So 1x cubed, 2x squared, minus 5x, minus 10. Don't put the 0 down. That's just the remainder, right? So the cubic. 1, negative 2. 2 minus negative 2 is 4. Negative 8. Negative 5 minus negative 8. It's 3. I don't think that's going to work. Okay, so let's change this to, let's try x equals negative 2. And let's change this to x plus 2. let's just clear that out. It's easier to clear out with a pencil, right? But, okay, so 2. 2 minus 2 is 0. That'll be 0. Negative 5 minus 0 is negative 5. Negative 10, 0. Okay, that works. All right, so I mean, either you graph it. If you graph it, you know what, go into the table, right? You're looking for integral zeros. You know they're between negative 10 and positive 10. Graph it, go into the table. Don't bother looking at the graph. Go into the table, find a couple of zeros. Then say, I'm going to try this, right, as if it won't work, right? I'm going to give this a try, and okay, it works. In this case, I actually did try it, and it didn't work, so we tried something different. Okay, so what do we got? We have x plus 1 as a factor, and we have x plus 2 as a factor. Was it x minus 1? I can't see it, it's off the screen. Okay, we got x minus 1, x plus 2, what's this? X squared minus 5, right? X squared, no x's, minus 5. X squared plus 0x minus 5. Okay. This solves plus or minus root 5, right? Okay. So now we go to solve, right? So we don't need to do anything fancy with this. I could factor it, but am I really going to write x plus root 5, x minus root 5? No, I'm not really going to write that. Okay, so now, what are we doing? Well, now we're solving, right? So we know that x is equal to 1, negative 2, and, okay, let's just go over here. X squared minus 5 is equal to 0. X squared is equal to 5. X is plus or minus root 5. So plus or minus root 5. Now, what degree was it? It was 4th degree. State the real roots. Here they are. 1, negative 2, plus or minus root 5. The equation is of degree 4 and has, and then, okay, 4 real roots, no non-real roots, right? 0 non-roots. Since the graph has 4 distinct real roots, right? They're all different. The corresponding graph of this function when using the, okay, so this should be what? Since the equation, the next change on the list. Since the equation, change this to equation, abbreviated EQ apostrophe N. Since the equation has 4 distinct real roots, the corresponding graph has 4 X-intercepts. Verify this by graphing. This is left as an exercise for the reader. You can try this out. If you graph left side, right side, you would find 4 intersections, right? Between these two things, there would be 4 intersections. Equations where there are factors that have a multiplicity of more than 1. The distinct real roots of the equation, x minus 1 quantity squared, x plus 5 quantity cubed, x squared plus 4 equals 0, are, okay, what are the real roots? 1, negative 5, no real roots. It says real roots, man. There's the distinct real roots. Okay, stop there. 1 and negative 5. Because 2 of the factors have a multiplicity greater than 1, then the equation has 2 equal real roots with a value of 1. Right? So there are 2 roots. We call them 2 equal real roots. And 3 equal real roots with a value of negative 5. Now, x minus 1 squared, x plus 12 is equal to this. This equation is of degree 2, 6. So degree 1, 2, 3, 4, 5, 6, 7. So degree 7. And has how many real roots? 2. No. There are 2 and 3. It has 5 real roots. How many equal roots of 1? 2. And how many equal roots of negative 5? 3. Okay? So if there's multiplicities, then there are multiple. We call them equal roots, right? But there are 2 real equal roots, and there are 3 real equal roots. And how many non-real roots? So these guys have to add up to 7, right? Just as these guys have to add up to 5, these 2 have to add up to 7. Since the graph has, okay, now is it graph? It's the equation, right? Gonna throw an equation again. Verify that since the graph. So since the equation has how many distinct real roots? Distinct real roots? There are 2 distinct real roots. The corresponding graph of the function when using the zero method has how many x-intercepts? 2. Okay. Now, one of which you're going to see a touch and go, right? And you're going to see a change in direction, point of inflection, right? So you'll see the cubic, and you'll look at that and say, oh, that's multiplicity 3 and that's multiplicity 2, right? You know that from days ago. So that was days ago. I know everybody knows that. Okay, let's just graph the equation. I'm just going to do it here. All right, what did we have? X minus 1 squared. X plus 5 cubed. X squared plus 4. Okay, so there we go. Yeah, well that got worse, so let's it's going the wrong way. Okay, so there's the 3 roots at negative 5. It's not the greatest scale on this thing, but there you see it doing this, right? You've got the change in direction at the point of inflection, called the point of inflection, the change in direction. Change in direction at the point of inflection. And then here, you can see it coming down. You know, I should zoom in better. I can zoom in better. Okay, so there's that, right? It's just pretty steep. Verified by graphing, so we verified by graphing. Write an integral polynomial equation of degree 3 in factored form with the following roots. Okay, so we have 3 roots, right? So we have to take each root and turn it into a factor, right? So we're going to take each root. So we'll start by saying x equals 3 halves. Right? So if that were the tree guy on, what was it, something of the universe guy?
Oh, I am Groot.
I am root. Yeah, it's going to say I am root. Then 2x is equal to 3. So then that would say I am factor. Okay, so x equals 3 halves is the root. The factor is 2x minus 3. Right? And it's integral, right? So it's got integers. So I'm not writing, I don't write x minus 3 halves equals 0. That's not integral, right? So, but 2x minus 3 is integral. And then we've got x is equal to 3, basically plus or minus root 5. So we're going to turn that into x minus 3 equals plus or minus root 5.
Why is it plus or minus, not just?
Well, I could do them one at a time, or I could put them both together. So I'm just putting them both together.
Oh.
Okay. You could do them one at a time. Then we're going to square both sides and get x minus 3 quantity squared is equal to 5, because either way, plus 5 minus 5, when you square it, the root, which gives me x squared minus 6x plus 9 is equal to 5, which gives me a quadratic factor of x squared minus 6x plus 4 is equal to 0. So here's the roots which become these two factors, right? Or a factor of second degree. So this is the factor. Yep. Yeah. It's this. It speaks louder than 1,000 words or 4 words.
Why is there only one if it goes plus or minus? Like, would there be two?
You squared it.
Oh.
So you'd end up with the same regardless, right? Whether you just said plus or minus. If you just wrote x is equal to 3 minus root 5, you're going to end up with that anyway.
Oh, okay.
And then if you did it again, you just say, oh, I just end up with the same thing.
Oh, okay.
So let's just do it once. So what's factored form? Write an integral polynomial. So y is equal to 2x minus 3 times x squared minus 6x plus 4. Actually, not y equals, right? Where a polynomial equation is equal to 0. So we give you the roots. You determine the factors that have that as a root, right? So if you take x squared minus 6x plus 4 and find the roots, you're just working your way back. Well, you wouldn't do it this way, but you use quadratic formula or square root principle, and you get back to this. Okay. If you use the quadratic formula on this, this is where you're going to end up. Okay. It's going to be ugly, messy, and it's going to take a little while, but that's where you'll end up. Yep. Yeah. There are two roots here, right? Because it's quadratic, so quadratic has two roots. There are actually two real roots. We know this because we know what the roots were. This is not root of multiplicity. It's not like x plus 1 squared, which is the root of multiplicity 2. This is just a quadratic.
How do you find
Degree 3. I got squared and negative 1. You multiply that out, you're going to get 2x cubed and then a whole bunch of other terms. If you take the two terms, in factors, if you take the terms of highest degree and multiply them, you'll get the degree of the polynomial. Okay, so 2x times x squared, 2x cubed. Everything else just gets smaller. This will be an x squared term, an x term, an x squared term. So they'll all collect together. Okay. But we wanted the factored form, right? In factored form. The product of three integers is 3,900. Two of the integers are odd and consecutive. The third integer is 5 more than the largest of the two odd integers. Graphically determine the three integers. All right. So I have a solution on the paper, and but I'm going to use it because I don't want to go free here and just say. So we need to get an odd integer. Here's how we get an odd integer. So we say, if x is an integer, then 2x is an even integer. Okay, so if x were 5, 2 times 5 is 10. You're going to get an even number. If x is 7, 14. If x is 8, 16, right? So 2x is an even integer, right? Because obviously it's divisible by 2. So to make an odd integer, what do we do with an even integer? You add 1. Okay, then, or say, and 2x plus 1 is an odd integer, right? Must be odd. So we have to force an odd integer, right? I mean, in theory, you could say, let x be an odd integer, then the next one is x plus 2, and then the next one is x plus 7, and try it, and just make sure at the end that your x was in fact odd, because you said it was, and if it comes out even, then you have a contradiction. But if we force this, we know 2x plus 1 is odd. Okay, so two of the integers are odd and consecutive. So what's the first integer is going to be 2x plus 1. Okay, so first integer. What's the second integer? So it's 2 more, right? So it's a consecutive odd integer. Okay. And then what's the next one? So what's 5 more than this, considering this is the largest one? 2x plus 8. Okay, if this is what you think it is, then you should check and make sure that it really is. So if I say x is 7, then this is going to give me 15. What's the next consecutive odd integer? 17. What's 2 times 7 plus 3? 17. What's 5 more than that? So the third integer is 5 more than the largest. So it's 17 plus 5, 22. It's a product of 3 integers, right? So it doesn't say the third integer is odd, right? It just says the third integer is 5 more. Okay, I put a 7 in there, I get a 22. Good. So I've got the numbers that I think I should be getting, right? Okay, using that as a formula, right? So I have 7, I get 15, 17, and 22. I've got 2 consecutive odd integers, and then I've got the third integer, which does not have to be odd, but it doesn't say there, third integer is odd. Graphically determine. Oh, life is easy. We just get to graph this, right? Graphically determine. Okay, so what are we trying to solve then? Well, what's the product? It's equal to 3,900. Okay, so graphical determine, I can graph the left side as y1, the right side is y2, find the intersections. I could just graph 2x plus 1 times 2x plus 3 times 2x plus 8 minus 3,900 and look for the zeros. Okay, got a choice? What do you want to do? Look for zeros or extend the window up to 4,000. What do y equals? Make a choice. What's it going to be? y1 is the left side, y2 is the right side? Fine, let's just do it that way. y1, so here I'm going to say what y1 is equal to 2x plus 1. Don't expand this, right? You're just going to enter it into your calculator this way. y2 is equal to 3,900. Okay. Now, I'm not going to pick a window yet. I'm going to do a little stuff to figure out what my window should be. So I'm going to go 2x plus 1, 2x plus 1, times 2x plus 3, 2x plus 3, times 2x plus 8, 2x plus 8. And I'm going to hit enter, and y2 is going to be 3,900. And I'm going to go second function table. So I'm basically looking for when is y1 3,900, right? When is y1 3,900? Or is it 6? It's right there. Okay, 6. All right, so that tells me that my x values can go from whatever, negative 10 to 10 is fine, right? Because I'll see the 6 in there. So I'm just going to go zoom standard to do that. And then the y values, we're not going to see much. Just things are going to, because we're supposed to be looking up at 3,900. Okay, so window. Okay, so negative 10 to 10. And y min 0 to 4,000 by 500 graph. So we saw it earlier, there was actually something cubic looking going on around here, right? So that's what we're interested in. Okay. So set my window, said x. I could cut it down, but negative 10 to 10 by 1s, my y's. 0 to 4,000 by 500s. Okay, find the, now here's where it's important, right? It's find the x-coordinate of the point of intersection of the two lines. Find the x-coordinate of the point of intersection. Right, so graphical determination requires, well, we should also sketch the graph out. So. Okay, 3,900 on 6. So find the x-coordinate of the point of intersection. Okay, which is x equals 6. Okay, so to do that, second calc intersect. I'm just going to go up to that curve because it's easier to move along the red line. And 1, 2, 3, 6. Okay. Now, what did the question actually ask? Graphic. Determine the three integers. So we know x is 6. What are the three integers? Okay, so if x is 6, 2x plus 1 is 13, 2x plus 3 is 15, which are consecutive odd integers, and then the third integer is 20. And on your calculator, you now want to sit down and go 13 times 15 times 20, and you should get 3,900. So the integers are 13, 15, and 20. Okay, and you can verify that by multiplying 13 times 15.
You can also use 2x minus 1, 2x plus 1, and 2x plus 6, and you get 2.
Yes, as long as, yeah, so you got 2x, then 2x minus 1 must also be odd, and then 2x plus 1 will be odd, yeah. So there's any number of ways you can state it. I'm willing to bet you could use x plus 2, and x plus 7, do it, and that you will get x being, well, x will come out as 13 then, right? So I haven't tried it, but I'm willing to bet it'll work. But the thing you have to do if you do it that way is when you get the x, just make sure that when you do the numbers that you have two odd numbers, right? Because maybe you just found a solution. See, we forced this. 2x plus or minus 1 must be odd. We know it is an odd number regardless of what x is. If I just say let x be the first odd number, x plus 2 be the second odd number, and then the third number is x plus 7, I risk finding an even value and saying, oh, here's the values, and it's like, no, it's not. Okay. But I'm willing to bet that it would work. This is exercises for you. There is a wording change, and there are solutions to this in Schoology, which hopefully by now everybody has signed up to. Whose is this? And the word, you want to use the world's best pencil sharpener? And the wording change is this one, graphically. Graphically. So with the emphasis on graphically, I'm willing to bet, and I have not yet seen the test, but I'm willing to bet somewhere on there it's going to say graphically determine something. Okay, that there will be a graphical. So make sure you know what to do, right? Here's my y1, here's my y2, or here's just my y1. Here's my window. I graphed it. Here's a sketch of the graph. I find if it's y1, y2, I found the x-coordinates of the point of intersection. If it's just y equals and then 0, then I found the value or values of the x-intercepts. Okay, and then answer the actual question, right? This would be the radius of the balloon to the nearest 100. It's got to be of a centimeter. So make sure you put centimeters on the answer for this. And